All right, so now we're going to start with our calculations. So we are going to take a look at the problems that involve direct relationships first. Okay, so this is part two, looking at direct relationships. So when I'm talking about direct relationships, I'm talking about the problems where we have like V1 over T1 equals V2 over T2, or something like Charles's law, Gay-Lussac's law, and Avogadro's law. So really on your review, there are really only two of them. All right, so we have temperature and volume here in number 10. And so let's just take a look at this one. So the first thing that you guys need to do is you need to identify your variables. Okay, so it says a sample of gas occupies 40 liters at 28 degrees Celsius. What volume does the sample occupy at 0 degrees Celsius? So, we're looking at volume, and temp. So you will look at your list of your equations that you'll have, and you'll say, okay, which one of these is volume and temperature? So it is Charles's law. And our equation, we want to write it down. Okay, let's write it over here. So V1 T1 equals V2 T2. And so what I have taught you guys to do is identify your variables, actually write them out. Okay, so our volume initial volume, and our initial temperature, V1 and T1. And then we also have a final volume and final temperature. All right, so let's identify these. So it says a sample of gas occupies 40 liters. So I'll put 40 liters here. And our temperature is 28 degrees Celsius. And it says, what volume does the sample occupy at 0? So our x, the unknown, is going to be our final volume, but we know that our final temperature is 0 degrees Celsius. Okay, and what we know about temperature when we have an ideal gas is that we must use our temperature unit in Kelvin, because that is the unit of temperature in these gas law formulas. All right, and so we find that by taking our temperature in Celsius and adding 273. Okay, that equals your Kelvin temperature. So where we have temperature, we want to add our 273 to both of these, 273. So 0 plus 273 is 273 Kelvin. And so over here we have 273 plus our 28, and we get 301 Kelvin. Okay, and so now we're just going to plug these in. So we have 40 for V1. We'll just put V1. And then our T1 is 301. So that's our T1. It equals our V2, which we've identified as X. And then our T2 goes on the bottom, which is 273. So this is our V2 and our T2. So we are just plugging these numbers in that we have identified. And so now we are going to do a little cross multiplication and division. Okay, so you cross multiply and divide. So this ends up being 301x equals 40 times 273. All right, so 40 times 273 is this huge number, okay, but we are going to divide that huge number by 301 divided by 301, and we're going to get 36.2, let's say. Okay, so 36.2 is our answer. All right, so that is that one. So I would say on the quiz, the majority of you knew how to do that cross multiplication and division. So that is going to work out great. So this is going to equal your final volume. All right, and that is what our question asked for. All right, so let's look at the other one. And this one I want you to pay particular attention to. So in class, we've talked about Avogadro's law, and we've talked about where in Avogadro's law, we're dealing with our volume and our number of moles, so little n. So we have our initial volume over our initial number of moles equals our final volume over our final number of moles. And it states this in the problem. So we have our volume here, we have moles here, and then moles here, and it's asking us for our final volume. So it says when a 40-liter balloon filled with 30 moles of helium has 3 moles of gas added to it, what will be the final volume of the balloon? So we want to first, just like all of them, write out our variables. Oops. So we have V1, N1, V2, N2. All right. It says when a 40-liter balloon filled with 30 moles of helium. All right, so that's our initial 40 liters and 30 moles. And then it says of helium has 3 moles of gas added. So N2 is 30 plus 3, 33 moles. So really what I want you guys to remember is that when you're talking about Avogadros, it's often that you have to calculate that final number of moles by subtracting or adding. You just have to check the wording in the question. It's super important so that you don't accidentally have your final volume, final number of moles be 3, because that's just the number of moles that you added. So just watch out for that. Okay, and so we're going to assign x to our unknown value, can't speak. And now we're going to plug this in to our formula. All right, we cross multiply and divide. We get 30x equals 40 times 33. And so let's do 40 times 33. That is this number, 1,320. Now equals 30x. We need to get that x by itself. Okay, so we divide that by 30. And we get 44 moles. That is our answer. Okay, so this is how you do that cross multiplication division that you see with our direct relationships. Okay, hopefully that was helpful.